How did I get started in electronics? Well, when I was about 7 years old, I started taking everything apart that was electronic in the house, including those old AM radios where they might have been from the 70s and they had a baby blue color case and they have the pulley inside, so you have a dial to change the station on the AM dial. Then there's a pulley string thing going along and it pulls along the indicator that shows what frequency you're at. Well, when you take this apart and you want to try and undo that string and then you try and put it back, I don't know, I could never get it back together. So I guess I broke one too many things, and when I was about 10, I got this kit. It's a Logix Cosmos kit, and this kit, well, this is copyright 1976. I got it in the 80s, and it was kind of an advanced kit for a 10-year-old. I pulled my first ever all-nighter. You got these different color bases, and you had to insert all of these metal conductors in the first place before you could even get started. You had to bend your own wires. You had all these components. You had to bend the leads and insert them. And in particular, the transistors were pretty awkward, and I didn't know the difference. Like, this is going out in 3 different directions to plug in the transistor, so you had to bend the legs, right? I didn't know where the flat end of a TO92 is supposed to go, and I might be crossing the legs over trying to put them in, so a lot of the projects didn't work for me, and in any case, it was worth it. I mean, look at this 70s police car. How can you go wrong? Some projects, bistable multivibrator, and it shows you how to connect the things. To a beginner who's also a kid, it's kind of advanced. So it didn't deter me. By the time you get to the end, you're winding your own inductors for an antenna for a radio. And I always liked this resistor color code thing. I like how they have these brown-bodied carbon composition resistors here. But yeah, here's how fancy the kit can get. You have a plug-in earphone, and you've got this radio antenna over here, and you have all this circuitry. That's pretty advanced. But I stuck with it. And then I graduated to this, well, there's not much left of the cover, 160 in 1 kit. Now this one's a lot easier to deal with. You've got these spring contacts, and all you got to do is follow the instructions that say connect a wire from this spring terminal to this one and this one to that one. And yeah, I had a lot more success with this. Everything I ever tried to make worked. A light-dependent resistor to turn things on and off, a relay latching circuit, DC to DC converter, lamp blinker, which is an incandescent flashlight bulb basically, light dimmer. It's basically a lot of simple transistor circuits, and it really is easy to work with. It shows you the diagram of how the wiring goes. It tells you what springs to connect to what. They're all numbered, so they give you the wiring sequence here. You can just blindly follow the sequence and clip the wires in, and then you've built the circuit in the schematic. So that was easy. And then, of course, there's the 130 in 1 version of the kit I got a little later. Same sort of idea, spring contacts, a little bit more advanced perhaps. It had a couple of ICs, including some digital stuff, a quad 2-input NAND gate, and a dual op amp. But really, what got me going was Forrest Mims, Getting Started in Electronics. This book, I guess this is the 4th printing, 1986, and I think I got this in 1986. So this is really old. It's kind of getting tattered. It's interesting how it was 3-hole punched as if it's supposed to go in a binder, but really if the binder is any amount big, you can't really open this. So I don't know if this is coffee stains, cola stains, or ferric chloride. It could be any or all of those. So yeah, Radio Shack used to be the one source that I got components and books, and this is under the Archer brand. There's more burn holes. I don't know what's going on here. Something burned through. I'm thinking ferric chloride. I think I was trying to make my own PC boards and I spilled the stuff. I think it's just that the pages got wet and it soaked through and it looks like it was burned. And obviously something here like coffee cups or cola cans were put here over the years. Now, the thing about this book, I like how it's all handwritten and it's got these little drawings all over the place that make it more entertaining. But it's easy to follow for beginners. So you start out with some basics of electricity, how electrons flow, and you start talking about components and then semiconductors and then anything to do with photons. So LEDs, photodiodes, phototransistors, solar cells, then digital ICs and all kinds of theory, how to build a logic circuit. Then you get into more analog stuff like op amps, timers, function generators, voltage regulators, some practical tips on building a circuit, and then you get into some projects. So, it's very simple and basic, but, how to use a 78XX, 7805, 7812, 7815 DC regulator with a wall transformer, bridge rectifier, a couple of filtering capacitors, and a voltage regulator, linear. How to use op amps, how to use a breadboard. What does it look like underneath all these holes, This was my fundamental go-to resource for a long time, and around the same time I got this, I was really getting interested. I got my first breadboard. I got the larger version of this tiny one, so about the typical size, and I'm sure I still have it somewhere in this basement. I have to find it. And I also got my first multimeter, this folding analog meter. I was starting to get really serious at this point, and then of course you get all of the Forrest Mims Engineer's Mini Notebooks, basic semiconductor circuits. So that's essentially things with transistors. This is also 1986. So semiconductors, diodes, Zeners, bipolar transistors, JFETs, MOSFETs, UJTs, SCRs and triacs. Just a whole bunch of theory and circuits. Formulas, tables, basic circuits. I kind of bought this just to kind of have the collection, but I don't know that I really got anything out of it. Like resistors and capacitors in series and parallel. Like it's basically an Ohm's law kind of thing. Digital logic, gates, talking all about TTL, counters, divide by, and then CMOS, how to interface back and forth between TTL and CMOS, starting out with the basics of logic, on, off, light bulb on with a battery, light bulb off. How can you go wrong? What are circuits all about? Oh, 555 circuits. I believe this would be where I found the Atari Punk circuit, the stepped tone generator. Some pinout diagrams as a reference. Oh, this one's 1984. Oh, look at all of that. Monostable mode, astable mode, making a switch debouncer, I suppose, a touch activated switch, a timer, frequency divider, pulse generator, voltage controlled oscillator, audio oscillator, metronome, toy organ, stepped tone generator. That would be what Atari Punk was based on, right? All kinds of circuits, all kinds of theory. 555. Optoelectronics. This one is losing its ear. So this one talks a lot about incandescent and LEDs, what you can do with light sources, even neon flasher. This is really falling apart. So again, lots of circuits, op amps, inverting amplifier, unity gain, non-inverting amplifier, all kinds of things, single and dual supply circuits, integrator, differentiator, lots of things happening in here. It's mostly based on the 741 and the dual 741, the 1458. All kinds of stuff. And then I would get things given to me once people knew that I was interested in this stuff. Radio Shack again, a realistic guide to oscilloscopes. I believe this is the early 70s, 1972. And obviously these are old school vacuum tube looking scopes. In the 80s I had one like this. I don't know why I got rid of it. I don't think it was broken or anything. And it had a green CRT. I loved this thing. It wasn't practical for doing accurate things, but I wish I had it now. It was huge, it was heavy, it was just like this. It even had a single strap to carry it around, and I was always afraid the strap's going to break. This book, I don't even remember what's in here now. Well, talking about cathode ray tubes, because obviously that's what oscilloscopes have in them. How the cathode ray tube is made, and how to use a scope for various purposes. Yeah, there's just all kinds of diagrams and things you can do with a scope. XY mode. And of course, along the way, you need to buy books like this video descrambler book, Rudolph Graf and William Sheets. You know, how to do TV descrambling. Isn't it annoying in the 80s when you have to pay to get cable? Well, ooh, political, legal, and consumer aspects of scrambling. I guess they got to cover all bases, but there's all kinds of diagrams and info, data sheets. I couldn't really understand all of this at the time, but it was fun to have. Magazines. This was my first electronics magazine, Radio Electronics, October 1986. It's kind of hard to see, light gray on obnoxious yellow. I was in 7-Eleven, and they used to have 2 arcade games at a time, and they would rotate them monthly. I guess there was a provider that would come in, and 7-Eleven would get a cut, and so of course I was hanging out by the arcade machines, and one day I looked at the magazine rack because it was right beside the arcades, and I saw a circuit board right there, and it's glaring yellow, so this is advertising at its peak. I saw this thing glaring at me from the distance, and I said, "What is that?" And it was a couple of dollars back then, so I had to have it. I took some of my quarters from what I was going to play games with, and I bought this. This one happens to have a satellite TV descrambler, some oscillators for your breadboard, build an old-time crystal radio, burn your own EEPROMs, not E-squared PROMs. We're talking the UV erasable EEPROMs, how to build a programmer. So, you know, all kinds of things in here. Ooh, I wonder if I can send this away and get business reply mail. Projects, including the schematic and some theory, a parts list, places that you can buy the parts. But in the back, ads all over the place. All kinds of ads for products and companies. JDR micro devices, 74LS series logic chips. You can get a 74LS00 for 16 cents. 20 megabyte hard drive for only $389. EEPROMs, a 2716 for only $3.49. These ads are the way that I discovered companies like Jameco and Mauser. Even Radio Shack had ads. Oh, this looks exactly like the Radio Shack catalogs. I think I have a couple, like 1986 and 1987 somewhere. I remember seeing pictures of the components, and I just wanted the components and I wanted to know how to use them, but stuff like buying memory chips, I wouldn't know how to use those. Voice synthesizer, melody synthesizer, I think I had this. I always wanted this stuff just by seeing it in the catalogs, and that helped me stay enthusiastic about it. So yeah, this is how I really started branching out, finding projects. Look at that guy. All electronics, and look at this. DigiKey. So once I realized there's magazines about this stuff, well, I had to keep buying it. Okay, build the radio electronics robot. And this one, March 1989. Lasers. Build a universal power supply and put any laser tube, helium neon laser tube, to work. I bought this kit and I made this. It's somewhere in this basement. If I dig it out, I will show it and see if it still works. I don't know if I have multiple laser tubes. I have at least one. Now, from what I remember, I bought the laser tube separately from the kit. I think the kit came from somewhere in New York, and it is based on a 555 oscillator, and it generates high voltage with a capacitor diode multiplier, and the 555 sends pulses into a transformer. So you generate maybe a couple of thousand volts at low current, and you power a helium neon tube. And I think I got the laser tube at Meredith Instruments. I remember being on the phone with them and talking to some girl about what they sell and what kind of milliwatt outputs, and I'm just a kid. And I made an order over the phone. And I got this thing and I built it and it worked. 1989. There's the laser right there. I've got to look for this and see if it still works. So there's the laser tube. There's the transformer. Here's the 555 circuit. It's got a couple of pots. I can't remember what they do. Here's a power switch. I think this is a transistor on a big metal chassis heatsink, which pulses the transformer. I'm not sure. And then you've got your high voltage multiplier. It's got plexiglass on top to protect it. You're supposed to use aquarium tubing to help insulate the wiring for the high voltage. And the laser beam comes out from here. That was fun stuff. Oh yeah, VCRs. Anyone remember those? Then, of course, there's other magazines. Popular Electronics. Build a Van de Graaff generator. Ooh, 1992. Look at that. Tandy computer. Guitar headphone amplifier. 1995. The end of 1998. Build a countdown clock for the millennium. How many days left? 1999. LCDs. The easy way. This is only like a couple of years before Arduino. Arduino was the early 2000s, right? So, how to use an LCD with microcontroller circuits and just doing it the old school way. There's other stuff like modern electronics. 1990. Interfacing 555 timers to the real world. HP scientific calculator. I don't know what model this is and what I have, but I have one very similar to this. I bought it about 8 or 9 years after this ad though, so I'm not sure. Maybe I need to find this. It was expensive. Computercraft, 1993. This thing showed how to design circuits for interfacing with a PC. Pinouts for the 8-bit card slot. Directly accessing a PC bus. I always wanted to do that, never got around to it. Artwork to make a PC 8-bit card. Circuit Seller. Oh, this one's from 2002. So this is really just before Arduino came out. So here's a circuit. It looks like it has an Atmel AT90S 1200. Back when schematics had individual components, not just an Arduino with a couple of wires going to another circuit board and a bunch of software. And this one, 1993, the Maplin magazine. Digital train control system. Now, I don't remember how I came across this magazine. It wasn't something normally on my bookshelves, but when I saw it, I had to have it. It's got all kinds of fancy things in it. Ooh, LCDs again. Some practical theory on impedance matching. And some old school circuitry again with individual components back before everything was microcontroller. Here's that big model train thing. Flow charts, circuits. This was using a PIC 16C54. Good stuff. And this one, ETI Electronics, 1992. How to make a PCB expansion card for an 8-bit computer slot. And they used to give you printed circuit boards. I don't know what this is. They gave you an etched circuit board for a project. Hey, maybe I should make this. I gotta check into this. What is this? But yeah, how to make an 8-bit card for a computer. Nice, discrete digital circuits with all kinds of write-up. And this mysterious stain coffee or whatever. Again, fun stuff. So this is how I got started in electronics. In the early 80s, taking things apart that I couldn't put back together, getting into electronic kits, getting into individual electronic books and magazines. Then I went on and got a diploma at a community college for electronics design. I worked in manufacturing, building surface mount boards on an assembly line, so I got to work the solder paste screener machine and the pick and place machines. I worked at the end of the assembly line doing manual inspection of the boards under the magnified lamp, functional testing, and debug and repair. Then I went back and got an engineering degree and became a full-fledged engineer. Then I started learning more advanced things and getting a lot more experience, having more funds available to expand all of this stuff, and now I'm just having fun. If I had to pick one thing to be grateful for that helped me on my way, it's this book. You can still get this book today. It doesn't have the same cover, and it doesn't have all of the unique stains that mine does, but it's a good place to start. So today everything is all more advanced with mechatronics, and you have Raspberry Pi and Arduino and all these other FPGA boards all set and ready to go. And you can get them cheap, and you can get all kinds of sensors on pre-built boards. But when it comes down to it, when you need some fundamentals, this is how I got started in electronics.